So the first method that I want to work on is deposit because the logic is pretty simple. The user will provide an account ID and the amount that they want to deposit into the account, and we'll do just that. Now we're going to need the account ID because the user can have multiple accounts, and we're going to have to make sure that the account belongs to the user attempting to deposit the money. Now this can be changed based on what you want. If you want a user to be able to deposit into any account, that's fine. But I have a separate method for that, which is handle send, which will allow you to send money to another user if you want to. For this deposit is going to be strictly for the person that owns the account. Two annotations I want to add to this method that's going to help with concurrent requests and making sure that the transaction actually saves properly is first, obviously the transactional. We utilized that already, but the transactional. And I'm not gonna add any crazy metadata. The only metadata I'm gonna add is the rollback, which is going to make sure that if there's an exception, it's going to roll back that transaction. So just got to specify what type of exception that we want it to roll back for. And in this case, it's going to be an exception, the exception class. Now, in the future, I am going to change the exceptions to utilize a runtime exception. And when we use a runtime exception, this rollback metadata is not going to be needed. So this will be changed in the future, but for now, we're going to need this. The next thing that I want to add is the lock annotation, just to make sure that it handles concurrent requests properly. And I got to import that. Now, being able to handle concurrent requests for deposit is very important because, say for instance, there's a withdrawal or there's a send. I want to make sure that when I'm depositing money, that I'm reading the proper value because I don't want to have an issue where somebody withdrawed money at the same time and now I'm still seeing the amount before the person withdrawed. And when I add money to the account, it's not going to see the withdrawal. So now the person has more money than they should have. Now, when it comes to auditing, that information is going to be a little bit finicky because this person has more money than they should because someone withdrawed at the same time that I was depositing. So handling concurrent requests using locks is very important. But like I said many times, you want to make sure that you handle deadlocks properly and that you research on the pros and cons. But in this case, I'm going to utilize a pessimistic write that will make sure that when I'm depositing into this account, nobody else can read, nobody else can write. When I'm done, then somebody else can go ahead and read and write. But while I'm trying to deposit money into this account, only I can read, only I can write. I'm going to utilize the value is equal to lock mode type dot pessimistic write. And I'm going to need a couple of things. I'm going to need the user service. So I'm going to do private file user service. And I realized late that I wasn't utilizing private for my injections, just for extra security, making sure that other classes don't have access to it. Only this class does. Um, and then I'm going to do private val account service. And I'm going to grab that. Now, right above here, I can start the logic of the deposit. So what I want to do first is, like I said, making sure that the user is actually the user. Even though I know that I'm going to be retrieving the user ID from the JWT token, I always like to do my due diligence of making sure that it's the proper user, right? This is the user that I expect. And then I'm going to grab that user ID, grab that user, and making sure that that account belongs to that user that I just retrieved. So I always do my due diligence. But if you don't want to make an extra query, if you just totally believe that the user ID is coming from where you expect it to come from, then you can just utilize user ID. But just for me, just for extra security, I always just check. So what I'm going to do is do file user is equal to user service dot get user by ID and just provide the user ID. And then get user by ID is just returning an optional, meaning it can either have an instance of the user or it can be null. So I have to make sure that I handle that as well. So I can do dot get or else. And what this is going to do is either going to get the instance of the user if it does have a instance of the user, or else I'm going to go ahead and throw an exception, meaning there is no user with that user ID in the system. So I'm going to say user does not exist. So second line is going to be file account, and I'm going to grab the account based on the account ID that the user provided. And I'm going to do account service dot find account by ID, pass the account from the fund DTO as to account because we're depositing, so we expect the user to provide an account to the to account. If we're withdrawing, then we're going to say from account ID. But in this case, we're depositing, so we're going to utilize the to account ID property. Now, this find account by ID, it is going to return an optional of account, meaning, like I said, with user, he's either going to return an instance of the account if it's available, or it's going to be null, which we got to handle that. So it's going to be or else throw, and I am just going to provide an exception that it will throw if the account is not available. So account not found for the user. Cool. And then if we're able to have a user and the account, we have an instance of both. All we got to do next is check if that user ID is not equal to the account dot user dot ID. Meaning if this account is not associated to the user that we just retrieved, then we're going to throw an exception. Account does not match user. Now, there are many ways you can go about doing this. The user itself has an instance of all the accounts that is associated to that specific user. We remember we created a one-to-many relationship. So if I do user dot accounts, I have a set of all the accounts associated to that user. So another approach would be iterating through those accounts from the user that we just retrieved and checking if the ID from the funds ETO is inside of that set. Uh, but it's really up to you on what approach that you want to take. In this case, I just retrieved both and checked if the ID is associated to the user ID. But there are other ways that you can go about checking that. Now, the next line I want to do is account, because we have the instance of the account, meaning we have the instance of the balance of that account. And what I'm going to do is do plus equal funds DTO dot amount. So now we're just adding that amount as a deposit. We're adding that amount to the balance. And last, what I have to do is create a new transaction. So luckily we have a method that allows for the creation of a transaction pretty easily. So we can do create transaction, and all I got to do is provide the variables. So user ID or underscore ID is going to be equal to, well, the user ID that was provided. Uh, and then I could do that the amount is going to be equal to the funds DTO dot amount. Then lastly, I'm going to do transaction type. It's going to be equal to transaction type dot deposit. So that's really all we need in that regards. So that means we can erase this piece right here because new transaction is going to hold the instance of a transaction, and we just got to pass it here. New transaction and new transaction. And we just got to do one more save, and we have an instance of the account service which we injected. So we can do account service dot save account and provide it the account because we did add the amount to the account balance. So we have to make sure that we save that change that occurred with the account. Then afterwards, we just return the new transaction, and that's pretty much deposit. So that is the first method. We can now move on to withdraw. Now for withdraw, the logic is very similar to handle deposit. I'm going to check if that user exists. I'm going to check if the account also exists. And here is the option here if you want to keep this logic on whether or not other users can withdraw from the account or whether you would just want to keep only that specific user to be able to withdraw from the account. I'll leave that logic up to you. But in my case, I'm going to keep that. I'm going to make sure that only users who own the account can withdraw from the account. Um, that will be, my case, right? It's very similar to Cash App. Random people just can't come and withdraw money from your account. You have to either send the money to their account or they can make a request. That can be a separate thing that you add. And another piece of functionality that you can add to this funds app is sending a request. So even I might do that later on. So yeah, only individuals who own the account can withdraw from the account. So I already kept that 3 lines of code or a little bit more than 3 lines of code here. Then the next piece will be checking if the account balance is enough to withdraw from. So if the account balance, and I'll start that process here, if the account dot balance is less than the amount that you're trying to extract from the account or withdraw from the account, then go ahead and throw an exception. You don't have enough money to withdraw from, right? So throw an exception, not enough funds for withdrawal. And then the opposite case will be if the account balance is greater than or even equal to, right? It really depends on if you want to allow your account to stay at zero or get to zero. If you're one of those funds app that you don't want an account to get to zero, then you will have to do less than or equal than here. But in my case, I don't mind if the account is equal to zero, that's fine. Just don't go negative. And then, if it's greater, if the balance is greater than the amount that is, being retrieved or attempting to be retrieved, then that's fine. Just go on with the logic. And that logic will be just deducting that amount from the account balance. So it'll be account dot balance minus equal to funds DTO dot amount. And then it'll be the same process of, and let me remove this. And I'm going to copy this new transaction piece. And the only thing I really got to change here is the transaction type, which is going to be, in this case, withdraw. And to specify that I'm going to be utilizing new transaction here. And if you want to make it specific, you can do withdraw transaction, naming conventions when it comes to variables. Sometimes I get a little lazy. I will be honest with that. So new transaction, because this is a new transaction technically. I guess that's not a bad name. It's not a terrible name. But that is pretty much logic for handle withdrawal internally. But on the outside, what type of things can we utilize to making sure that we handle concurrent requests properly? Now, just for demonstration purposes, I'm going to make this utilize a heavy duty locking and isolation for consistency. But like I said, it will increase the risk of deadlock. Now, during my time of discussing about transactions and locks, I did talk about serializable, and we already utilized pessimistic right. But what happens when we utilize it together? Well, remember, serializable is a more restrictive isolation level, ensuring that transactions don't interfere with each other, while pessimistic right is a locking mechanism that ensures exclusive access to a piece of data. Like I said with deposit, making sure that other people can read, other people can write, only I can utilize this row of data just to prevent concurrent updates. So for handle withdrawal, I just wanted a scenario to show how to use serializable and pessimistic right. And I believe this is the case where it can shine the best. Honestly, if I'm just being honest, just pessimistic right would be enough in this case, as the isolation level already established exclusivity. But I just wanted to show how you can utilize serializable as well. I'm going to use the annotations again, and I'm going to start with the transactional one, transactional, and open that up. And the isolation level is going to be equal to isolation dot serializable. And the same concept for rollback. Rollback for, and specify exception here and the class of that exception. And then secondly, I'm going to use a lock, right? And the lock is going to utilize the value of lock type or lock mode type dot pessimistic right. So in other scenarios of withdrawal, not specifically this one, because for this withdrawal, you have to own the account to withdraw. But for other scenarios, with a task like withdraw, where a user account can be very active, for example, the user runs a business and people are constantly withdrawing from it, this can be helpful because people will have to wait in line to withdraw data from the account. The system has to make sure that there is enough money to withdraw from the account. But like I said, it also increases the chance of slow performance and deadlocks. So research, making sure that you have ways to handle those situations, and then go from there. And rookie mistake, I forgot to save the account, so it's gonna be account service dot save account, and just passing the account so that it shows what just occurred. Right, we deducted money from the account, so we should save that account. All right, so now it's time to handle transfer. But before I do that, I want to go over a mistake that I actually made that I'm going to actually keep in, just as a warning to always be careful for copying and pasting. And that's here. instead of it being to account ID, it has to be from account ID because we're withdrawing from the account that the user specifies in the request. So copying and pasting can save time, but you also got to be careful that it's handling the logic that you want it to handle. So that is that. Let's head over to transfer. Now for transfer, there is going to be one thing that I actually need to do before starting the logic, and that's in the account service. I'm going to have to create a separate method for handling multiple saves because for future methods, we're going to need to handle the ability to save multiple accounts at one time. We could save the account individually, but just to save time and just so you guys can actually see how you can do it, I'm going to create a separate method that will show you how you can save multiple accounts or multiple entities really, because this can be done with any entity. You can save multiple at the same time. So I'm going to go below here and I'm going to call this method fun save multiple accounts. Now you could just call it save accounts and make it plural, but just to save me for myself, because sometimes I might not see that, then add an S, and it's just to save time to know that this is going to handle multiple accounts. I'm going to name it as that, and then open that up, and then accounts is what we're going to accept as a param, and it's going to be a list of accounts, and it's two C's. Now out here, I expect to return a list of accounts from this method, right? And then return from the account repository instance dot save all, right? And this is save all from the Spring JPA. This is a method that is provided by default. We didn't have to create this. This save all is going to allow us to provide a list of entities, and it's going to save all of the list of entities or all of the items in the list. And that is the account that we're providing through the parameter. So cool. And then above here, all I'm going to do is add at transactional. So it's going to be a similar logic to withdraw, but not exactly the same because we're going to be handling two accounts. We're going to have to retrieve the accounts associated to a user, but it's not just one account that we did with withdraw. We're going to have to withdraw from one account and we're going to have to essentially deposit into another. But both of the accounts have to belong to the user when it comes to transfer. So I'm going to copy this first two, but I'm going to keep my head on a swivel because I know of the mistake that I made before. And what I'm going to change here is simply the messaging. So I'm going to say for the exception, instead of saying account not found for the user, I'm going to say source account is invalid. And I'm going to change the name of the variable to from account just to make it more obvious of what this is. And then I'm going to copy this line and provide this underneath, and I'm going to say to accounts. And I got to change the variable here to account ID. And instead of this being the source account, this is going to be the destination account. So the logic is we're going to get the user ID, check if the user exists. If the user does not exist, then it's going to throw an error. Then we're going to retrieve both the accounts associated to the user, the from account and the to account. If either one of these accounts don't exist, then it's going to return an error. And if they do exist, then we can continue on with the logic. Now, like I said, we're going to have these two accounts, and we have to validate the ownership of these accounts to the user. And like I said, there are multiple ways you can go about doing that. You could grab the instance of the account set that's in the instance of this user, and then iterate through them and check if both of these IDs exist in that set of accounts. But what I'm going to do is I'm going to create a separate method that's going to work as a helper method to help validate the two accounts to that user. And just to make this a little bit quicker on time, I'm just going to paste in that logic here. And it's called validate account ownership. It's going to take in a user as a param. It's going to take in the from account, the to account. And what it's going to check is if the ID of the user is not equal to the ID that is associated to the account, then it's going to throw an exception. So if any of these two is true, then throw an exception. If not, then we can continue on. So I think of this as like a speed bump. So what we can do is use validate account ownership and provide in user, provide in the from account, provide in the to account. And now it gets to this point. If it's invalid, then it's going to throw an exception. It won't go beyond this point. But if it is okay, then it's going to run the next line of code. And the next line of code is another piece of validation. And we got to check if the from account balance is enough to deduct from. So just like with withdrawal, we have to check if the account balance is greater than the fund's DTO amount. Or another way that you can think about it is if the from account's balance is less than the fund's DTO amount, then it's just insufficient funds. So we can do that by using an if statement, just like we did before. If from account dot balance is less than funds DTO dot amount, then we can throw an exception of insufficient funds in source account. Now, if this is okay, then we continue on with the logic. If not, then obviously it's going to throw an exception. But if it's okay, then we can go ahead and start updating the balances of both of the accounts. So we could do from account dot balance, do minus equal funds DTO, DTO dot amount, and I got to utilize that funds DTO, and to account dot balance plus we're depositing that money that we're transferring over from one account to the other, funds DTO dot amount. And then for this piece, the transaction piece, we're gonna erase this, and I'm just gonna copy from above here just to save some time. The new transaction for transfer. So we can do transaction type is gonna be transfer. The amount is gonna be fine. The user ID is fine. So when it comes to transfer, we're handling two accounts. We're handling from account and to account. And remember, when with the create transaction method, these two are optional. They're not required, they're optional. So what we can do now is we can provide those values because we didn't have to use both of them before, but now we could. It's optional, but in this case, it's not as optional because transfer handles two accounts. We can go ahead and provide both values. So we could do from account equals from account ID, and we can do to account is equal to account ID. Cool. And then we can go ahead and save that new transaction and then return the new transaction. And the last thing that I have to do is utilize the save all that we created in the account service. So we can do account service or the save multiple accounts, but it's utilizing the save all from the repository. We can do save multiple accounts, provided a list of the from account and the to account. And that's just going to save the changes that we made to the accounts, right? Deducting the balance for the from account and adding to the balance for the to account. And one thing that I realized with saving these account IDs is that I didn't actually save them for deposit and withdraw, but we can specify what account we're withdrawing from. So we can do from account ID here and set that equal to the account ID. So that should work for that. And then for deposit, we can do the same. And we can do to account here. So to account ID is going to be equal to account ID. So same concept. What account are we depositing to? Well, we're depositing to this account. And what account are we withdrawing from? Well, we're withdrawing from this account. So same kind of logic, and we don't need to utilize both because like I said in the parameters, they're optional, right? Whichever ones that we don't use is going to default to null, and whichever ones we do use, well, it's going to pass that value into it and it's going to save it. So just a little fix for the other ones as well. But for the handle transfer, we're finished with the internal logic, right? It's going to check if the account's associated to a user once we validate that they all exist. And then it's going to check if the balance has enough funds. If not, it's going to throw an exception. It's going to handle the logic of the transfer by deducting the balance with the amount that's specified in the request and adding it to the second account or the to account. And then it's going to create a new transaction where we save what occurred with that account or with both of these accounts in this example. And then we go ahead and save that transaction, and then we save the changes that occurred with the accounts. Now, when it comes to handling concurrency, what should we use? Well, honestly, it's going to be the same concept. I'm not going to go as heavy duty as serializable, but we can just utilize the same isolation level, which is the default isolation level, and we can utilize the pessimistic write lock for handling concurrency issues, right? Because with pessimistic write, remember, is going to lock the row of data, so meaning you're not going to be able to read, you're not going to be able to write. We're handling a transfer in this case. Nobody else has access to it, and that should be enough. Now, if you want to lock it down, then you go ahead and use serializable, but I don't believe it's necessary. I just showed serializable to show that there are other ways that you can lock it down even more, but you just got to be careful of deadlocks. Cool. So that is handling transfer. Now we can move on to the last one, which is a little bit more, I would say, plump, and that's the handle send. All right, so for handle send, this will be when you're trying to send funds to another user. Like I said, this logic for send is a bit, let's say, thick. So that's why I'm saving it for last, the best for last, of course. Initially, the logic is somewhat similar. We're going to have to retrieve the user and the from account because if we're sending the money, is in the case of the user making the request. So I have to make sure that the user making the request is first valid so that the user actually exists, or in this case, I can change the message to make it a little bit more specific to be user attempting to send does not exist if that user does not exist. And then for the from account, what I can do for this case, if it's not available or if it's null, sender account is not valid, or you can say invalid, but just to inform them that that account doesn't exist. And that's the from account, right? This is the individual that's sending the money, who made the request to send the money. And the next thing that we got to do is check that the account that they're trying to send the money from actually belongs to them. So it's a little quick check of if user that ID is not equal to the from account dot user dot ID. And honestly, I'm realizing I don't even have to open up the curly braces. This could be a one-liner. But let me take from the exception here and then just adjust the message a bit. So account or sender account does not belong to the user. Cool. And then the next thing that we can do is then validate that the user that they're trying to send the money to is actually a valid user. So what I'm going to do is create a variable here called toUser, and I'm going to make that equal to user service. And you got to make sure that you have the proper dependencies injected, the account service, user service, transaction repository. And from the user service, the user service dot get user by email, because in this case, we're utilizing email because in the funds DTO, and let me go to that definition of funds DTO, we have the receiver email. So to make that send request, you need you need the email of the user that you're trying to send the money to. It's just like, Cash App or just like Zelle, and specifically Zelle. Zelle lets you, and if you're not from the United States and you don't know what Zelle is a service that allows you to send money to other individuals, and usually they ask for things like phone number or email. So it's similar to this, right? Um, in this case, we're accepting email. You can add, phone if you want to, or other properties that define a user. But in this case, I'm accepting email. So from here, I can validate that that user actually exists by email. So I can do funds DTO dot receiver email. And the same concept, right? I'll just literally take this dot get or else and paste it right here, right? Gets or else throw an exception. But in this case, it's going to say um, recipient does not exist. So the person that you intend on sending the money does not exist. Now, the next thing that we have to do is not that when I realize I didn't spell recipient right. So the next thing that we have to do is grab the default account ID from this instance of user. Because remember, we created the default account ID, right? Which was created when the user was created. When the user signs up, this default account ID is set up because a default account is created for this user. So we're going to attempt to grab this default account ID, and we can utilize that account ID to send the money to. So back in the fund service, now that we have the instance of the user, we also have the instance of the default account ID. And what we can do is check if that account is valid. Now all I gotta do is create a variable here called toAccount ID, and that's just gonna store the value of the default account ID if it's available. Because remember, default account ID could be null, right? Maybe the individual end up closing all their accounts and that account doesn't exist anymore, then it's possible for it to be null. So we do have to check for that. So to user dot default account ID. And I'm going to use the Elvis operator to check if it's null or not. If it's null, then go ahead and throw an exception. Recipient must have a send account set up, right? You need a default account ID for this send to work. It's just like with Zelle. Like with Zelle, if you attempt to send money to someone who doesn't have Zelle set up, then it's going to let you know that that recipient does not have Zelle set up. So you can either inform them, whether through phone or email, that, hey, set up a Zelle account, and then I can go ahead and send you this money. Or you can find another medium to send the money. Maybe you can mail them some cash. Now, you could also double check that this account ID belongs to this user, but because I'm grabbing the default account ID from the actual user instance, I believe that extra check will be unnecessary, but it is optional, or it is an option for you to do that, but I won't be doing that. So the next thing I'll do is check if the balance in the from account is enough to send to this new account after I finish retrieving the account, of course. So now that we have the to account ID, what I can do is I can retrieve that account and we can start the process of the send logic of deducting and adding the money from the account to another account. But I gotta actually retrieve that account. So let me do val to account, and what this is gonna equal to is the account service dot find account by ID, and then we could pass that to account ID that we just retrieved from the user, which is the default account. And it's gonna be the same concept, right? If this is null, then go ahead and throw an exception. I doubt it'll be null, but just in case, it's always good to have a little fallback. And we can say recipient. So now what we can do is we can do another check of checking if the balance from the account has enough. So it's going to be very similar to withdraw. It's going to be very similar to send. We got to do if from account dot balance is less than the account that the amount that we're trying to send to the other account. Then what we can do is, and this can be a one-liner as well, throw an exception, insufficient funds in the sender's account. Now, if we get past this part, meaning that we have enough money in the account, we can go ahead and do the math, right? So we can do from account dot balance minus equal funds DTO dot amount, and to account dot balance plus equal funds DTO dot amount. Cool. So we updated the balance. Now all we have to do is save the transactions. These transactions are a bit special because of the fact that we're interacting with accounts that belong to two separate users. So we're going to have to create two separate transactions to show that. Right? We're going to have to create a transaction for the user that's sending the money, and we're going to have to create a transaction for the user that's receiving the money. So what I'm going to do is I'm going to erase this, right? And I'm going to grab this, and I'm going to change it to from transaction. This is for the person sending the money. And I'm going to change the transaction type to send. The user ID is going to stay the same. The amount is going to stay the same. The from is fine, right? We are taking the money from, the account that we specified, and we're sending it to the to account, right? Which we retrieved using the default account ID, which is fine. So this is normal. We didn't have to change much in this, only the transaction type. And the second one is going to be the to transaction, right? This is the person receiving the money. And we're going to change the transaction type to send. But the thing that's going to have to change in this case is the ID, because we want to make sure that when a person queries for their transactions to see what changed in all of their accounts, right? What interacted with their accounts. We want to make sure that they have something that they can utilize to reference those transactions. In that case, it's going to be the user ID. Now, if we just utilize the same user ID for the person that made the send request, then the person receiving the money won't be able to see that transaction. So we have to specify the to account user ID here, right? It can't be used the from account user ID for both of these transactions. We have to specify the other person involved user ID for this user ID here, so they can see the transaction in their history. Now you're probably thinking all you have to do is to accounts dot user dot ID, or you're probably thinking, oh, I could probably do even something better, to user dot ID. Easy peasy, right? But no, Kotlin does not like no values, right? How often do I have to tell you that? But no, Kotlin really doesn't like no value. So we're gonna have to utilize some magic here to make sure that Kotlin is okay with the fact that, you know, this is a correct value. This is not a no value. You're gonna have to mess around with it just a bit. So to do that, all we have to do is to user dot ID. Do a nice little safe call here. And then we're going to utilize let. And we're going to wrap this with curly braces and specify this user ID as it. And let me explain really quick. So Kotlin has a thing called scope functions, and what this is going to do is it's going to let us run this snippet of code if this ID in the to user instance, if this ID in the to user instance is not null, then it's going to let us run this piece of code internally, and it's going to return that value. And now that to transaction will hold the return value that's inside of this let scope. And the it is simply just a property that we checked beforehand to see if it's null or not, right? And in this case, it's just ID. So it is referencing ID, the one that we just checked. So we're injecting that into this little snippet. It's pretty cool. Now, if it is null, then what we could do is just throw an exception here, right? We could throw an exception, and let me do recipient does not exist, but most likely it's not going to get this far, because if the recipient does not exist, it would have never even got this far. That is an option. We don't need this. I'm not going to actually include it. But if you want to use the else operator just in case that returns null and it doesn't run, you could do that, but you don't have to. Now, after that, now that we have both of the transactions and we did the logic for the accounts, we're going to have to save those changes. So we're going to have to make multiple saves for multiple entities. So we're going to need multiple saves for a transaction, and we're going to need multiple saves for accounts. We can utilize the save all, right? So I can do transaction repository, since we already have direct access to the transaction repository because we don't have a transaction service. You could create one if you want to, but what I'm going to do is transaction repository dot save all, and I'm going to provide it a list of from transaction and to transaction. So that should work for that. And what I can do is account service dot save multiple accounts, provided a list of the from account and to account. And what transaction to return? We had two transactions. Well, in this case, it's going to make the most sense to return the from transaction, because the from transaction is saving the reference of the transaction based on the person who actually made the send request, right? The person that made the send request, this is their information. So go ahead and return that, right? Because you're only going to call this method based on the person that's actually attempting to send money over. So they would want to see their own information, not the other person's information. And they shouldn't have access to the other person's information as well. So that is the internal logic of handle sends. So it's going to check if the user exists, check if the account exists, check if that account is associated to the user. Then we can go ahead and grab the user that we're attempting to send the money to based on the email that is specified. And then that will also be a check if that user exists. Then grab the account ID based on the default account ID stored in the instance of that user that you're attempting to send the money to. and then grab that account, check it if it actually exists. If it does, then we go ahead and check if that balance actually has enough money to send over. If it does, then we can do the rest of the logic of deducting the money from the account, adding the amount to the person that we're sending the money to, and saving the transactions and returning that transaction. Like I said, this is thick. And the last thing that we got to do is handle concurrency. And we know how to do that. Um, all I'm going to do is add a lock, pessimistic writes, making sure that while I'm handling sending the money that nobody else reads and nobody else writes. We want to make sure that because we're sending money, the account will reduce in amounts. And if somebody reads the wrong value, then that'll be a problem. So adding a pessimistic write ensures that nobody else reads the value, and adding a pessimistic write also makes sure that nobody else can write a value to it. So if someone attempts to withdraw money from it, that doesn't cause issues as well. So I can do that by adding this lock like we did before, pessimistic write and transaction, making sure that it's either all in or it's not going to handle the transaction at all. And we have the rollback for exception. So that is the logic for the fund service. It was a lot, but it was effective.